Right, so it was a little numerical methods homeworky thing at the end of core 3, mock exam next week. And first question said the gradient, that didn't mean anything really, except does, did it? The gradient of the curve y equals, the gradient of the curve y equals 2x squared plus 9 all to the power of 5 over 2 is 100 at the point P. Show that the x coordinate of P satisfies the equation there. So actually the first thing you needed to spot here, and it was a little bit mean actually, was that was the gradient that we're trying to talk about. So actually the first thing we have to do, if that's what the function is, then we're going to have to differentiate it, aren't we? So we've got y as being 2x squared plus 9 to the 5 over 2, so dy by dx. So you see, it looked like it was all going to be numerical methods, but they've squeezed in a little kind of chain rule differentiation question there. Good, well done. Right, so this is the chain rule. We could do our substitution and call the inside function t and the whole thing t to the 5 over 2, or we could think of it, remember, as big bear, little bear. So the big bear is something to the power of 5 over 2, and something to the power of 5 over 2 would go 5 over 2 times something to the 3 over 2, but then we've got to multiply by little bear, the inside function, which would be 2x squared plus 9, and if we differentiate 2x squared plus 9, we get, Dan, that was you. Great. So we multiply by 4x. The 5 over 2 multiplies by the 4 to give us another thing. What's that? Is that 10? 2x squared plus 9, 3 over 2. So that's what dy by dx is. X. Oh, I've lost the x. Thanks, Josh. You can be the resident X spotter. There we go. And we're told that at the point P, it's 100. So at P, this is equal to 100. 10x, 2x squared plus 9, 3 over 2 is equal to 100. And the question wants us to rearrange it to get the form x equals. Well, because we've got the 2x squared already in that bracket there, it must be this x we're focusing on. So let's divide both sides by 10, 2x squared plus 9, 3 over 2. And of course we can write that 10 over 100. 100 over 10 gives us 10. And this is 2x squared plus 9. So minus 3 over 2, and we got there. And we did it in quite a few steps. We got 3 marks. Show by calculation that the x coordinate of P lies between 0.3 and 0.4. There are a few ways that it would be acceptable to do this, but the nice way of doing this is to turn this into a function that's equal to 0, and then work from there. So what we're going to say is that we're interested in 10 lots of 2x squared plus 9 to the minus 3 over 2 minus x being, let's call that g of x, if we rearrange that. And then let's sub in these values, so let's sub in g of 0.3 and g of 0.4. And let's see what we get from that. Do I have to do this? Right. Oh! And you could... Should we do the table thing just because it looks great? Is that on the screen? Yeah. So what do we do? Mode and 1, no, 3, the table. The function, slightly complicatedly, is 10 brackets 2. Where's x on this one? X squared plus 9 to the power of minus 3 over 2. Look at this. Brilliant calculator work there. Minus x. We're going to start at 0.3. We're going to end at 0.4. We're going to do a step of 0.1. We're going to get a table. There it is. Oh, isn't that great? And there are the values. Oh, that doesn't work. There. So that was 0.05953. Oh dear. And this one was minus 0.04854. We have change of sign. And remember, the other thing that we're going to say here, just to be extra careful, is that the function is continuous in that range.
Good. You might.
I like 2 marks though.
Yeah. You want this mark, not put it in.
It's continuous in that range because the only discontinuity, we're dividing by this bracket here as part of what we're doing. So that would be if that bracket were equal to 0, and of course that bracket can't be equal to 0, so we know it's continuous. Therefore, a root between 0.3 and 0.4. So there we go.
If you don't put it's continuous.
Just to teach you a lesson on this, I'm not sure in the exam whether you would lose a mark for not writing that it's continuous. You might, but just to punish you, you're going to lose a mark if you didn't write it's continuous. Right, part 3. Use an iterative formula based on the equation in part 1 to find the x-coordinate of P. You should show the result of each iteration. Notice here it doesn't tell us where to start. What would be a sensible place to start?
1.
Bearing in mind what we've just been doing. 0.3 or 0.4 or 0.35, somewhere in that kind of region would be a sensible start point. The iterative formula based on this equation is going to be xn plus 1 is, what was that thing? 10 2xn squared plus 9 to the minus 3 over 2. And let's start at 0.3. It would seem pretty sensible to start at one of those two values. Start subbing them in. Again, we'll go back to our trusty calculator, and we'll go back to the standard mode. Remember how we do this? We type in our initial value, 0.3, press equals, and now we set it up to do the iterative stuff. So 10 times 2 answer squared plus 9 to the power of minus 3 on 2, minus 1.5, that'll do. And this should give us a new value, and my calculator has just said 0.359. How much accuracy do we want here? 4 decimal places, right, so we need to go a bit further than this. Let's go to 6, just to be absolutely certain. There we go. Let's do it again. X3 is 0.35496. X4, we've got 0.355342. Not quite there yet, are we? X5, 0.35531. We've had consecutive iterations that have given us an answer to 4 decimal places of 0.3553. We will do one more.
No.
Just to be absolutely certain, 0.35531. We've now had consecutive iterations that have been the same to 5 decimal places, so we're pretty much certain x equals 0.3553. Correct. 4 decimal places. There we go. And that's it done. Remember, you do have to show the result of each iteration. It did say you should show the result of each iteration, so it said it. We must do it. Great.
We've done a little red scribble.
And that's maths.
doing?
It's still
It's still